Hello everyone. Today I'll talk about a solution to the problem string compression 3. This problem asks us to perform a variant of run length encoding on a given string, where the length of any run can be at most equal to 9, so we might have runs of the same character next to each other. It's classified as a medium, but really it's not a medium, it's more of an easy problem. But since it's classed as a medium, I'm going to show you a solution that's not typical, as I tend to do with easy problems, short, using multiple built-in functions from Python, but something more imperative, more straightforward, because it's really up to your preference, or to the preference of the team you're working with, in what way you want to implement stuff like this. So the first thing that we should probably do when it comes to performing this run length encoding variant is to run length encode the string from the beginning and then just transform that encoding to the encoding that we want. So essentially we can first do the encoding without this at most 9 times and then transform it to the form which splits up so it splits up long runs into runs of size at most 9. To perform run length encoding, we can write code like this. So essentially in the list stage 1 we're going to be having pairs of character and the count of that character. So we have to go through all the characters, remember depending on if the character is the same as the previous one or different, we have to do something else. If it's different, we have to append the count of the previous character to the string, or to the stage 1 list in this case, and also we have to do that at the end. And I tend to write it in such a way that at first I remember that the previous string is the previous character is the first character of our string, and the count of that character is 0. Then the logic looks like this. So that's pretty easy. And now in stage 1 we have the run length encoded string from the beginning. Now, since I'm going to be operating on it as if it is a stack, so I will be modifying and eating characters from this stage 1 to create stage 2, which is this specific type of compression. I'm going to reverse our stage 1 string. So we could make that reversal at any point. We just have to select a point that's the most convenient. So this one is the most convenient for me. So now this is the run length encoded string, but reversed. And we'll be creating our final stage 2 string, which at the end, of course, it's created as a list. At the end, we will make it into a string using empty string.join, as it's typical in Python. And now we're going to be transforming all our characters from stage 1 in a while loop, so for as long as we have something remaining. What do we have to do? Well, we have to eat at most 9 characters from the top characters from our stack. So we take the value of the character and the count from our stack, and we're going to be eating at most 9, so the minimum of count and 9 characters of that type. We'll be putting that many characters, so our subcount of the characters we go into the final list. We have eaten that many characters, so the remaining number is count minus subcount. And if something remains in count, so this is the point at which the run is longer than 9 characters and we have to split it into a few smaller runs, we append it back to the first stage. So we have now eaten at subcount characters of the last type. If there are no more characters of the last type remaining at the top of the stack, we just don't do this append operation. And when we run out of characters, we have created our final string. So for this simple process, this is a pretty complicated code, but it's also possible to write it like this, to go step by step. And about those reversals, you can put that reversal wherever you want, or you can just not use this list as a stack, but iterate over it with a range loop, right? So either forward or backward. Notice that here, in our case, in our specification, we want the count to go first and then value, so we put count first then value. If we were to reverse the answer instead of reversing stage 1, we would have to append v and subcount first. But also if we were to reverse only at the end and not in the middle, then we'd have a problem, because our the problem statement specifies that, for instance, if we have 15 letters A, then it has to be transformed into 9A, 6A, and not 6A, 9A. So if the specification was different, and all the 9s should not be at the beginning but at the end, then that would be a nice opportunity to put that reversal somewhere else, because you would get that behavior for free. And of course, if you want, you can try to implement it in a much shorter way, if you prefer those more concise implementations.